Welcome to week 3. This week you're going to have two things that you need to complete. The first is in your textbook you'll need to read chapter 2, and then in D2L complete the chapter 2 quiz. It'll be for a homework grade. The second activity is going to be a Dropbox assignment where you're going to build and interpret a histogram from some process data. This week we're going to begin looking at the concept of variation. It's important to us in the world of quality because we consider variation normally to be bad, and we would like things that don't vary. We normally describe it as we like things that are consistent in nature. In fact, from the discussion posts last week, there were several mentions that hinted at this idea of variation or consistency. So one was the Innova golf discs. So the poster said, if you buy 3-star leopards, there is little to no difference in their flight characteristics. So part of the value of that brand was it didn't matter. Every time he bought a 3-star leopard, he could count on it flying just like anyone he'd ever used in the past, the ones that he practices with. So the consistency of that disc is what made it high quality. Someone else was fond of Benelli guns, and they mentioned their high reliability, right? Consistent performance is something that we would describe as reliable. And so again, the idea of low variation, high consistency. Then in one case, someone talked about variation, and they were talking about Folgers coffee. And Folgers coffee changed the source of their coffee beans, and so the user was dissatisfied, and they switched brands because of that variation. So in all kinds of fields, right, when we talk about quality, one of the things that we expect is consistency and a lack of variation whenever you use a certain brand or a certain product. Many of our efforts in the process plants toward improving quality are centered around understanding and reducing variation in our products. One tool that we're going to start practicing with that conveys a lot of information about variation is called a histogram. So to show the power of a histogram, we're going to look at a couple sets of data. So if you look at some data here on these classes that took exam 4. There's 3 classes, there's 100 students in each class, they all took exam 4, here's all their scores. And if you look, people might ask the question, well, which class did better? And so that's a little bit difficult to answer. One way that we would generally answer that question is we would look at the class average. So if you take the average of all 3 of these classes, you'll see that they all come out to about 75%. But these 3 classes performed very, very differently on exam 4. Now a histogram divides the data into bins or categories and then just counts up how many things are in each category. And so you have ranges of data and count the number of occurrences that fall into that range. So in class averages or distributions, we talk about like how many B's were there, how many C's were there, those kinds of categories. When you do that with this data, if you look at class 1, you'll see the grades vary widely. So no one grade seems to be representative of the class. There's lots of low grades, there's lots of medium grades, there's lots of high grades. It's very spread out across the class. Class 2 is much different. Still has an average near 75, but as you can see by this histogram, it performed completely different than class 1. There was hardly any difference in the performance from student to student. Everyone scored in the same range. There was very little variation. Class 3's histogram looks more like what you typically see in grade distributions. Many students score in a middle range near the average. Some do a bit better or worse, and only a few do really well or really poorly. Sometimes this shape is called a bell curve because it reminds people of the shape of a bell. So what kind of distributions are there? Well, one is a random distribution. So if you were to roll a dice, a six-sided dice or die, and then tally up the number of ones you get, the number of twos you get, the number of threes you get, and plot it in a histogram, you would expect it to be kind of the same number in every category. It's a random event of which one is going to come up. On other things, right, if you look at the distribution, it has much more that bell shape, and oftentimes in the real world, it falls into what we call a normal distribution. Not normal like in everyday or expected, like the English word normal, but it's actually a statistical word that describes that shape when that shape conforms to some certain mathematical properties. But it occurs very, very often. So it occurs whenever you're talking about student grade distributions, the weight of dog food bags, the age of professional golfers, the hours of sleep people get a night. All types of measurements fall into those normal distribution patterns. So it's a very valuable tool for us to understand what to expect out of certain processes and how to measure and evaluate them. So there's an article this week that describes how to use a histogram and how to use the shape of the histogram to get some insight into what may be going on to generate the data that then results in the shape of the histogram that you're seeing. So make sure and check out that article. Back to our class exams. We had averages of all three classes that were very near 75, but very widely differing variation among the classes. So we use another statistical term and a statistical calculation called standard deviation to try to get a better understanding about not just the average of the data, but how does the rest of the data look compared to the average. So in one way, you can think of standard deviation as sort of the average deviation. It's not strictly the average, but sort of like the average distance away from the mean of all the data points. So that's kind of the sense of it when you say the standard deviation. It's sort of like the average of the distance from the middle. So class 1, if we start looking again at it and we look at this term standard deviation, we take that calculation, we find that in class 1 the standard deviation was 14, and you can see the spread of the data is very high. By comparison, class 2 had a standard deviation of only 2.3. So you can see the distance from the middle, right, is very small. All the grades seem to be close to the middle. And then class 3, the standard deviation was 9.4. So kind of between those two extremes. So statistically then, the lower the standard deviation, the less variation and the more consistent the thing is that we are measuring. In this week's assignment, you're going to construct a histogram from some process data. So the process is a distillation tower that separates a benzene toluene mixture with most of the benzene boiling off overhead and most of the toluene coming out the bottom of the column. So we have to analyze the bottom of the column every shift and analyze how much benzene is actually in the bottom. The bottom, remember, is supposed to be toluene. So we have a limit on how much benzene is acceptable to come out in the toluene stream. So that limit is 8%. So we call that a specification. That's the specification for good toluene. It can contain no more than 8% benzene in that stream. So we take that data every day or twice a day, every shift, we record how much benzene is analyzed in that bottoms stream. So the data set you have is the bottoms of that column, the analysis is the percent benzene, and you'll build a histogram to show what does the amount of benzene in the bottom of that column look like over a period of time. There is a video tutorial on how to construct a histogram. I hope you find that useful. And then make sure and review the article again on the shapes of histograms and to help you with interpreting the shape of your histogram that you build. If you have any questions, send me an email in D2L. We'll see you next week.